Hi Cashew Nation, I'm Engineer JD, a structural engineer and a college and review center instructor. Today, let's discuss about Laplace transforms. Let's get started. For this video, we will discuss the definition of the Laplace transforms and where it is used. Also, we'll discuss some basic Laplace transform formulas to make you get familiar with the concept. And finally, let's discuss the calculator techniques involved, especially in multiple choice questions involving Laplace transforms. By definition, the Laplace transform, it is one of the integral transforms that convert a function in real variable, for example, a time domain, into a function in the complex variable, for example, a frequency domain. It is given by the formula, so that the plus of the function of t is equal to the integral from 0 to positive infinity of f of t times e raised to negative st dt. Now, Laplace transform has its many applications, especially in civil engineering. For example, many of the behaviors in civil engineering, such as deflection of beams, can be expressed as a differential equation. And one way to solve differential equations is to express it in terms of Laplace and then converting it back to the differential equation to get the solution. Of course, Laplace transform is purely theoretical, and here are the formulas that are usually used when converting from the time domain to a frequency domain using the Laplace transform. There's a lot of them, and here are the basic ones, especially the last one. Just point out the last one. Now, the last one shifts the Laplace transform by a units to the right, and the last one is called the first shifting theorem, and it's obtained by multiplying the function by the Laplace by e raised to at to get this shifting. Now, the rest are just formulas basically, and then just to point out then, here in the first formula, the Laplace of t raised to n is the gamma of n plus 1 all over s raised to n plus 1. The gamma here is called the gamma function, and if n is an integer, then the gamma function reduces to the factorial function. Specifically, the gamma of n plus 1 is equal to the n factorial. Now, since Laplace transform is purely theoretical, where does the Caltech play a role in this topic? So let's have an example. Here, we are asked to determine the Laplace transform of the function f of t is equal to e raised to negative 3t times quantity cosine of 60 plus 4 sine of 60. And here, we are given 4 choices, and one of them is the correct answer. Now, please remember that this technique only applies in multiple choice questions. Outside of it, you cannot use this Caltech. So how does it work? So let's go here in the comp mode. So the calculator now is in comp mode. Now let's calculate the integral based on the definition of Laplace. Let's press the integral. By the way, take note that the display is in line IO mode. Again, if you recall from our previous videos, you can check the previous videos. The line IO mode displays inputs on a single line, and in some cases it's faster than the math IO mode. Now, in the line IO mode, we press integral, and then let's input the function, so which is f of t. We have shift ln to access the e raised to something, is 1, and then negative 3t, negative 3, but we will use again the variable x, alpha parenthesis, we get x, and then close parenthesis, and then times this quantity. Let's input cosine 60 plus 4 sine 6t. Now, that's the function. Let's close. And then, let's multiply by e raised to negative st based on the definition of Laplace times e raised to negative st. But let's assign a certain value, any value for s. Let's say, let's assign s equals 2 for this. So let's write 2tx. Now, that's the entire integrand. Next, shift, close parenthesis, accesses the comma, and then the lower bound is 0. Shift, comma. Next is yung upper bound, which is positive infinity, but for this case, we will use something like 99, or let's say 50. Let's say 50. Let's use a large number. And then shift, close parenthesis, comma, and then the accuracy of the solution. So let's say 0.0001, and then close parenthesis. Now, if we press the equal sign, you will get this. So integrals are usually slow, but let's be patient, and we will have the answer, which is 0.4754. That is the value of the integral, which is the Laplace transform when s equals 2. Now, let's compare. Let's save this for our reference. Let's save this to variable a, shift store a, and then let's compare it with the multiple choices. So let's try letter A. Now, to do that, let's go back to the Math.io mode, Shift mode, Math.io 1, and then resolve format is Math.o 1, and then let's try letter A. Let's try S. Now, S is 2 based on the previous one. 2 plus 27 over S is 2 plus 3 quantity squared plus 36, and then press equals. You will get this 29 over 61. Convert it to decimal, SD, you will get 0.4754098361. Now comparing it with this one, they are the same. Again, the value is this, and then this one, I know, then this one. So you see, if we recall yung solutions, we have a third. This is the value of the integral, 29 over 61. And then this one is the calculated value based on letter A, and they are equal. And therefore, the correct answer is letter A. Now, you can try substituting it in other multiple choices, and you will get that the answer is different from the exact value which is at A. And that's how we solve Laplace transforms in multiple choice questions. I hope you learned something from this. Thank you everyone, and see you on the next video.